Hello, algebra students. Mr. Lawrence here, and this is your review for the test. Basically, what's going to happen is I have about 7 or 8 problems here. 5. I guess I didn't label this one. This will be number 6, and this will be number 7 down here that you can only see part of. And the best thing you can do here is pause the video, do all the problems you can see on the screen, and then watch my solutions, and I'll scroll down so you can see more. So go ahead and pause the video, see what you can do. All right, here come my solutions. If you haven't tried all 4, please do. I'm going to group this first one. Julia Glogi can tell you that you're grouping because there's 4 terms, right? And I see a GCF in this first term is an x, and I'm going to get a k minus 3. And then here, I don't see a GCF, but who was it? Megan Green and maybe Kaylee Kleckner, they came up with the idea of factoring out a 1. Normally, factoring out a 1 doesn't do anything. And again, it didn't do anything. There's a k minus 3 there, but that helped them realize that, oh, I've got another k minus 3 to factor out. So they're going to factor out a k minus 3, right? And I'm going to get the quantity of k minus 3 times the quantity of what's left. Well, there's an x, and over here there's a positive 1. And so there is your expression factored completely. All right, the red one, again, if you haven't tried it, first type of factoring you look to do is GCF. Can't always GCF, but in this one you can. I see a 4a. I'm going to factor out a 4a. Okay, and that'll leave me with a 2a minus a 1. And there we go. Okay, the green one. All right, the green one. I don't see a GCF. I looked for one, but I don't see it. So I'm going to do my ABC thing, right? So ABC, easy as 1, negative 12. Negative 45. Okay, and I'm going to multiply 8 times c and get 45. Now I need 2 factors of 45 that subtract to get negative 12. Well, if you see it right away, please go right to them. If you don't see it, keep going. But as soon as you see it, stop. I'm going to get 3 minus 15. That's negative 12, and you put x's on there, like Rocky Romano did the other day. All right, now we can go x squared plus 3x minus 15x minus 45 equals 0. So now I'm going to group. It's just like problem number 1 now, at least in terms of factoring. And so I'll group like that, put a plus in between, and there'll be a GCF of x. So I'll get x times quantity of x plus 3. And here there'll be a GCF of negative 15. And I'll get an x plus 3. Don't lose that equals 0, very important. There's an x plus 3, that's common. And an x minus 15 equals 0. And now I have to solve. I have x plus 3 equals 0, and x minus 15 equals 0. And of course, you'll end up with x equals negative 3, and x equals positive 15. So there is your solution. All right, you could write that as a solution set like this, negative 3, 15. That's a good way to do it. Or you could do that, either one. Now, why didn't we have to do that on the first 2 problems? Because they didn't equal anything. They didn't equal 0. All right, number 2, well, number 4, you got a couple choices here. You could multiply, do the ABC thing. You could. I don't want to. I'm recognizing that these are perfect squares. Yeah, this is a perfect square. I'm going to get a 5x. And this is a perfect square, and I'm going to get a 4. And it's subtraction. Remember, if it was this, 25x squared plus 16, this would be prime. You couldn't factor it. But it's not addition. It is subtraction. There's one negative sign. So this is going to factor as 2 quantities. This is one of the mistakes some of you are making. You're only doing 1 quantity. You've got to get 2 quantities. You're going to have 5x and a 4 in the quantity. You can have a 5x and a 4 in the quantity. Because C is negative, you're going to get one of each sign. Yeah, if C is positive, you have to have two of the same sign. How do you know what sign to use? Use B's sign. But if C is negative, you get one of each. Now it equals 0, so you have to solve 5x plus 4 equals 0 and 5x minus 4 equals 0. I'm going to solve these really quick, and I'm just actually going to go to a negative 4/5 and a positive 4/5. I expect that you should be able to solve these two-step equations without me showing every gory detail at this point. All right, number 5, looks like I ran myself out of room. Oh dear, what am I going to do? Well, I guess I can try to get myself more room. I'm not sure why the keyboard opened up. Let's move that out of the way. And let's move number 7. Yikes, it's not moving all together. There we go. I guess I lost my question mark here. There we go. And a 7. Let me move number 6 down. Oh, I like that all that moved together. All right. There we go. All right, so number 6, I've got a trinomial. I'm looking for a GCF. I do see one. I see it too. So I'm going to pull a 2 out, and I'm going to get a 2y squared minus a y minus 3, and it'll equal 0. Now I'm going to do the ABC thing, but I'm only going to do it on the stuff inside the quantity. Only this part right here. Okay, the 2 is factored out. He stays in the problem, but I don't use him anymore. So let's see here. A, B, C. Easy as 2, -1, -3. All right. So I'm going to factor or multiply A times C and get 6, right? And I need 2 factors of 6 that subtract to get -1. Well, how about a 2 minus a 3? So I'm going to rewrite this as 2 times, and actually I should probably go with a bracket there, right? That looks pretty poor, so I'm going to rewrite it. All right. So I'm going to get a 2y squared. Now instead of writing a -y, I'm going to write a plus 2y and a minus 3y. That's the same as -y, and a minus 3. That will equal 0. Ready to group inside that bracket like so, and stick a plus sign in between. All right, so I'll have 2, and then I'm going to factor out a 2y here. I'll get a y plus a 1. Okay, I'll factor out a -3, and I'll get a y plus a 1. That'll equal 0. And then I'm going to get a 2 times, factor out the GCF, a y plus 1, and a 2y minus 3. Now, I have 2 solutions. I don't have to worry about this quantity, this 2, because there's no variable there. So I'm going to solve y plus 1 equals 0 and 2y minus 3 equals 0. When I do, my solution set is going to end up being -1 and positive 1.5. And there you go. All right. Number 6. There it is. It's one of those area problems. I give you the length and the width, or the base and the height, and I tell you the area. Go ahead and pause the video, see what you can do with it. All right, here comes my solution. Well, I know that if I multiply the base times the height, I'm going to get 21, the area. So I'm going to double distribute here. I'm going to get 2x squared. Let's see, I'm going to get a minus 5x and a plus 6x minus 15. That'll equal 21. And I'll combine like terms. I get 2x squared plus x minus 15 equals 21. I don't want it to equal 21. I want it to equal 0. So I'm going to subtract 21 from both sides. And I'm getting bothered by this here. Oh, never mind. Okay, now it's going to work out nice. 21. So I'm going to get a 2x squared plus x minus 36 equals 0. All right, now I do my ABC thing. ABC. Easy as 2, 1, negative 36. So if I multiply A times C, I get 72. Sorry about that. Couldn't help it. Couldn't tell you it was coming because the sneeze was taking control. All right. Anyway, God bless me. So I need two factors of 72 that subtract to get 1. How about a 9 minus an 8? So I'm going to rewrite this as 2x squared minus 8x plus 9x minus 36 equals 0. All right. So I'm going to give myself a little more room here. That's right, this stuff doesn't like to move together. My fault. Oh, how about that? Okay, bring that 7 down. All right, so now I'm going to do my grouping. Always grabbing that sign in front of that number there. And I'm going to pull out a 2x and get an x minus 4. And I'm going to pull out a 9 and get an x minus 4 equals 0. And now I'm going to get x minus 4 times the quantity of 2x plus 9. That'll equal 0. When I solve these, I'm going to get x equals 4. And here I got to do 2x plus 9 equals 0. So x is going to equal negative 4.5. Okay, but it was an area problem, so I have to go back and plug it in. Now I know with negative 4.5, if I put it in, sorry, can't get it to stop, it's like out of control. When I plug negative 4.5 in this quantity, that turns into a negative quantity. That's not possible. We can't have a negative quantity. So I'm going to disregard, Jiminy Christmas, what is going on here? So I'm going to disregard this solution. I'm not going to count it. It's not valid. If I put a 4 in there, I get 4 plus 3, which is 7 inches. And here I get 8 minus 5, which is 3 inches. And so therefore, 7 inches times 3 inches is 21 inches. So, yikes, what is going on, ladies and gentlemen? Is one of you taking control of my smartboard remotely? I think you may have, and you're playing a prank on me. Can't get this to cancel. All right, hold on a second here. Okay. All right, I think I'm in control. All right, so let me see if I can reestablish my connection and finish up this video. All right, the connection is reestablished. We don't appear to be having the gremlins. So my solution set is 4, and then my dimensions are 7 inches by 3 inches. All right, last problem down here. The product of two consecutive integers is 1,482. What are the integers? Well, remember, we have to define our variables. Let n be the first integer. Okay. Then the next consecutive integer would be n plus 1. Be the second consecutive integer. Okay. Well, I need to multiply those. I need to take n times quantity of n plus 1. And I need that to equal 1,486. Oh, excuse me, 82. Notice it's the same problem with different numbers as the rectangle problem we just did. Yeah, it's the same thing. So I'm going to get n squared plus n, and then I'm going to subtract 1,482 from both sides so that it can equal 0. All right, there's no GCF hiding there. And A, B, C. Easy as 1, 1, negative 1,482. All right, so I need the product of A and C, which is 1,482. I need two factors of that to subtract to get 1. Well, that little square root trick should work pretty good on this one. I know in class in first period it didn't work on that one problem. I think it's because they were so far away from each other. I've got 38 and a half approximately for my square root. If I go up, how much? A half, I'm going to be at 39. Okay, well let's try it. 1,482 divided by 39, and that's going to be 38. That worked out really well. So I'm going to get n squared plus a 39n minus a 38n minus 1,482. Now some of you are thinking, oh my gosh, this is such a hard problem. Not really. Not really at all. If you work smart, it can be done fairly easily. So I'm going to factor out an n and get n plus 39. Now some of you are looking for the GCF here. You don't know what it is. Well, it better be a negative 38. Why do I say that? Because I need to divide this number by something that will get me an n. How about a negative 38? See, if it's not negative 38, then this isn't going to factor. So it's almost like cheating. So I'll check on my calculator. 1,482 divided by 38 is 39. Yeah. And so now I've got one more factoring step. I'll have n plus 39. That's my GCF, and I'll be left with an n minus 38. That's going to equal 0. Now this n plus 39 equals 0 will yield n equals negative 39. But this one, n minus 38 equals 0, will tell me that n is positive 38. And they're both correct. Now I need to find n plus 1, the next consecutive integer. Well, that would be negative 38. N plus 1 over here would be 39. You see, there's two sets of answers. You could get negative 39, negative 38, multiply those two. They're both consecutive integers, and you will get the 1,482. Or if you multiply the positive 38 by the positive 39, you'll get 1,482. All right, that's it for the review video. Mr. Laurence signing off. Have a good night, everybody.